Hello everyone. So yeah, welcome to my live stream. I've come to stream after a long time. Uh, so let's see. Welcome to my live stream. I've come. Yeah. So the voice was echoing. Let me clarify it. I need another screen to, as usual, to watch the uh, messages in the live stream. So yeah, what am I planning today? So we were doing the blind 75 and we completed like almost like 50% of the problems. We didn't solve any easy problems in the blind 75 list. So today what I'm thinking is going to solve company specific ones, like next few live streams that I'm going to perform. I'll try to look into a few company specific problems, and then I won't do an elaborate solution. I'll try to look into those problems quickly and try to explain it or make sense of the solution. And yeah, like whoever joins this live stream, feel free to follow along. Like if you feel the problem is easier, just skip it. Otherwise, just pause the video and try to solve that once I talk about the approach. So that would be the effective utilization of your time. So yeah, let's get started. So today I'm starting with Meta. I'll choose another company sometime later and do another live stream. So for Meta, I have sorted it for the questions asked in last 30 days, and filtered it for last 30 days and sorted it based on the frequency. Let's start with the first one, binary tree vertical order traversal. So okay, binary tree vertical order traversal. Let's read the question. Given the root of a binary tree, return the vertical order traversal of its nodes values from top to bottom, column by column. If two nodes are in the same row and column, the order should be from left to right. Okay, so here the tree is given. It looks like this. The root of the tree. They would have given the root of the tree, or um, the reference for the root of the tree as input parameter, and then we need to print it in the order 9. This is the first column, and then in the second column 3 and 15 as it is shown here. It's in the same column, and then 20 is the next column, and then 7. So vertical order traversal means column by column kind of output. Okay, so here in this example, let's see. So 4 is one of the column, 9 is another one, and 3, 0, 1. These three are in the same column, 8 and 7. Okay, I think it should preserve the order as well. I don't know. If two nodes are in the same row and column, the order should be from left to right. Okay, so here in this example, for example, see 3, 0, 1. So if these two are in the same level and same column, so 0 and 1, and it should preserve this order. 3 is the one at the top of the column, so that would be printed before 0 and 1. Makes sense. How should we go about solving this one? Let's see. I think I've already solved this one. Um, so let me look into the solution. I have a large code here. Um, okay, vertical order traversal. So I'm traversing from root to all the other nodes, and 0 and 0. Okay, vertical order traversal. Let's look into this one. Okay. Uh, So vertical order traversal, I have this method which takes the current node and then the order and the level. Okay. Root is equal to null, return. If not, if the map contains the order, tree map. Okay. Okay, what is this order? I'm not able to understand the order here. Map.get of order contains the level. Okay, I'm doing a lot of things here which might not be required. Okay, it runs successfully. And vertical order traversal, find min. Am I using this method, find min key? No, every references to find min key is commented out. So let me comment this one as well. And then column traversal. Okay, all the references to this one is also commented out. So let's simplify it. So where is this map coming from? Map is defined in this approach here. Okay, integer map, tree map, got it. In the other approach, I was doing a lot of things. I had a queue and I was traversing through a queue in order to get the levels, I think. It looks more like a level order traversal to me. Current column -1, current column +1. Okay. Current node, okay. It's more intuitive also as I thought as of now. Linked list, new pair of node, comma 0. Okay, and I'm adding the column values also in the column map. Um, so if already an entry exists for the current column, then I'm just adding it to that. Otherwise, I'm creating a new array list and then I'll add the values to that next column. Um, okay, there's too many things here. I'm just not able to column traverse. Okay, there is one DFS based traversal, and then this looks like a breadth for search since I have used Q here. Okay, I'm assuming this one is a replacement for this. No. Okay, let's just look into the focus on this solution here. Vertical order traversal, root and 0 and 0. So what is this vertical and order traversal is doing? And yeah, this is the method. It have created a hash map, which is which has a key of integer and value as a map of integer and the list again. Value as the map of integer and the list. So why do I need it? So let's see. So if map dot contains the key order, what is order in this case? I'm not able to understand. So given the root of a binary tree, the vertical order traversal of its node from top to bottom, column by column, the order should be from left to right. Okay. Okay, order is basically kind of column number, I would say. It's a bad naming choice that I have done. Not sure why I have done that. Okay, let's do it like column number. It doesn't look like it. This code is written by me as well, so because I usually have the consistent spaces. It's not like I was not in the right mind when I'm coding this probably. Okay. Okay. Yeah, now it makes sense. If the column number exists in the map, okay, this is based on the column. I have a map based on the column, and then I have the value. Value as another map based on the level and the list of integers. Contains the level and the list of integers. Okay. In the vertical order traversal, I see if the root is itself is null, I'm just returning, doing nothing. If it is not null, then I'm checking if the column number is contained in the map. If it is contained, then I'm just adding to that column number. Okay, I'm using this as a, in the value it's a tree map, and this one is a tree map too. Both are tree maps, not instead of hash map. Okay, both are tree maps here. If map contains key column number, map dot put column number and new tree map, and then map is equal to temp map dot get column number. If temp contains key level, temp dot put okay. Okay, I like this approach, but it is not very intuitive for me, like having a tree map and then it's traversing through each item and I'm maintaining a column and the level number as well here. So, and then I need to, okay, I'm traversing through everything. Vertical order traversal, root dot left column -1. It will be once when we go to the left, the column number will be current column number -1. I'm assuming the root will be 0th column, so this will be -1. And then level +1. So root will be 0th level means when I move to the left child or the right child, it will be level +1. So this all makes sense. And then at the end, I am aggregating it by doing this one map.values.stream.map inner map. Okay, inner map dot values dot stream dot flat map of list of stream dot collect collectors dot to list. So basically, in the inner map, all the values are streamed and then it is flattened into a single map. So inner map values means the levels, like whatever we had sorted based on the levels here. So for example, in this example here, 301. So 3 was stored as one list and 01 was stored as another list. So these were like, uh, okay, let me give you a clear representation here. System dot out dot rather than me explaining it. Okay, this would have stored it as like ordered by column and as well as the level as well. And then we are flattening the levels as of now and then trying to order it in just by column here. And then we will collect and add it as a list totally. So here, if we print this out, okay, we can see here. So -1 is the, okay, it's showing example for this one. Okay, -1 is the column name and then 1 is the level of this one. And then since it is a tree map, it is sorted uh, based on the column number here -1. It has one element with the level 1 and the element value is 9. And then 0th level or 0th column, it has two keys. One is 0th level and another one is second level. This is the first level, so there's nothing in the first level in 0th column. So uh, in the for the 0th level, the value is 3. For the second level, the value is 15. And then next column, moving on to the next column, this is the first column, column 1. There is only one value. And then at level 1, and the value is 20. And in the second level, or the second column, in the second level, the value is 7. So that is stored in that same order. If you look into this case, you can see here for the 0th level, there are two key values. You see in the 0th level, there is level 0, which is 3, and then level 2, which is 0 and 1. So this is also a tree map. So it is storing it in the same order, the order of appearance in which we traversed. We are traversing from left to right, so it appears in the same order. And then, yeah, and we are just flattening all the values here. So with the statement, doing the flat map and collecting it into a list. So we are collecting all the values of this one, like values are 3, 0 and 1, and then we are making a list out of it. So 3 and 0 and 1. And again for the outer map also, outer map dot values, we are collecting it and adding it to a list. So 0, 3, 0 and 1. So that will be a list and then that would be added to a external list. That's how we are getting these values. So we do not have to use the stream APIs in the interviews. Just for clarity, even the interviewers who are performing the interview might not be very well versed with that. So let's break it down into smaller steps, step by step transformation, and then explain it, and then we can convert that code at the end to this one, if we are comfortable. So the way I would make it more readable is so for okay, how would we go about it? for each of the columns basically. First thing is let's iterate for each of the columns. So for integer column num, so and that will be map dot keyset. And for integer row num, not row number, level, and then map.get column num dot keyset. That would give all the levels. So now for each level, whenever we add a array key, okay, let's take this one as map. We need this result, something like this. Okay, list of array list, that's the result. And then we will take this one, list of integer current level is equal to new array list. Okay, not current level, current column. Okay, and then whatever we traverse level by level, we will just add it to the current columns. So current column values dot add so dot get level. Okay, so this would give a list value, so I'm just doing add all here, and then once I complete one level, like all the levels, I need to add it to the result as well. So result dot add current column values. And if we do this, let's see. Okay, so this gave the same effect or similar effect, but I just didn't use the stream API. I just used the basic for loops and then transformed the output into simpler format here. Yeah, so let's keep it for now. Okay. Yeah, what are the other approaches? So this is one of the approaches. So we just vertically traverse through each of the node. We kept the reference of the current node, and then we kept the column number, and then we kept the level number. And then based on, okay, this organization, just remember this organization, we are organizing the output or the map based on the column number. This integer represents the column number, and this integer represents the level number. And then for each level, there can be multiple integers in that values. Like for example, in the same level, there are multiple values. So that's why we are having a list here. And then we are using pre-map in order to preserve the ordering in which we add the input. So that would preserve the order for us. So we are checking if the root is null or the node itself is null. This one, let's mark it as node in order to be generic. It doesn't have to be a root node always. So if the node is null, then okay, if the node is null, don't do anything. If the node is not null, then see if the column contains, if there is a value for the current column already. So instead of temp, let's name it as current column here. Current column map. Okay, so here now I'm checking like if there is no value in the for the current column, I'm just inserting the value with the current column number. I'm creating a new tree map, and then if okay, I'm trying to get the value for the column number here. Okay, if there was no value, I'm inserting it. If there was already existing value, I'm not inserting any value. I just get value for the current column. And then if the current level does not exist, then I'm just inserting a new array list into the current level. If the current level already exists, then I'm just retrieving the value for this one. So this one I will mark it as current level. Okay, so current level values. Okay, so this is the current level values. And then I'm adding the current value, whatever the node's value, into the current level. And then I'm adding that list value, making sure that I'm putting the list value. Like in case if it was get by, like if it was an already existing value, then we don't need this current column map dot put. But if we have created it as of now, we might have to add it. So current level dot add. Okay, current map dot put level corresponding. Oh, I think this looks like a redundant statement here. Let's see if it works without it. Yeah, it works without it. So since we are like instantiating based on the level, and here also we are getting the current level based on the level, we don't have to make sure that it's added again. So we can remove this one. And also this statement looks redundant as well. Yeah. So yeah, so these two, both of these statements we can remove. Yeah, this looks like much more simplified version as now and much more readable. Okay, if the node is null, then just return it. Otherwise, check if there is value for the current column. If there is no value, then create a new tree map into that value, and then just hold the reference for that, and then check if there is a list for the current level. So here I'm checking if there is a list for the current level. If not, I'm instantiating and adding a new array list, and then I'm taking the reference for that one as well, for the current level, and then I'm adding the value for the current level. So this is added to the current level, and the current level is added to the current column map as well indirectly. And then I'm traversing further by traversing to the node dot left by column number -1 and then level +1. And the same way, node dot right, I'm making column number +1 and the level +1. So that looks good to me. Yeah, and I wouldn't bother looking into other approaches. Here it's a bit cumbersome, but in just if we see column traverse tree node column number, we have the column number and then the map of column map. Okay, there's the column number and the current map. So here it is traversing column by column. I feel that okay, this made it simple as now. Like we are simultaneously traversing column by column as well as level by level and organizing the data. And at the end we are getting that data in the output format that we need. So yeah, this looks good to me. Let's move on to the next problem. Before going to that, let me read the messages. Okay, let's move on to the next problem. So we are done with this first one, valid word abbreviation. So valid word abbreviation. It's a LeetCode easy problem. A string can be abbreviated by replacing any number of non-adjacent, non-empty substrings with their length. The length should not have leading zeros. For example, a string such as substitution could be abbreviated as, but not limited to, S10N. S10N, okay? And sub4U4 can be abbreviated as, okay, substitution can be abbreviated as, okay, this one as well, sub4UP4, and then can be just abbreviated plainly as 12 or anything, okay, or any number of, like, okay, no substrings replaced, so it can be just abbreviated as substitution. The following are not valid abbreviations. Sub 5 okay, okay, there are like two digits. This represents like 55 characters in between. So the replaced substrings are not adjacent, are adjacent. So the replaced substring cannot be adjacent, has leading zeros, and it cannot have leading zeros, okay, and replaces an empty substring. So this is also not valid. Given a string word and an abbreviation ABBR, return whether the string matches the given abbreviation or not. A substring is a continuous, okay, makes sense. I don't remember, recall adding this one as well. So let's see how to validate this one. So we just have to return true or false in this case. So let me, this looks like too much code in order to do that, but let me see if there is any simpler way. Okay, what I'm planning to do is, like, basically if I encounter a digit, then I'll try to pass the entire number and then try to skip those many indexes in this string, and then for the other ones I'll keep checking the characters and then keep managing its equality. So okay, I think I am doing the same thing. I would need both of those indexes. Abbreviation index is equal to 0. I'll start with that, and int word dot index, word index would be is equal to 0. Okay, and then while both of those are less than its corresponding length, is less than abbr dot length, and word index is less than word dot length. Keep going, and then if abbr dot at abbr index is equal to word dot char at word index, then just increment both of those plainly. Okay, if that's not the case, then see if that's a digit, if the abbreviation is digit. Otherwise, then we can just return false. Okay, that's what exactly they are doing. Or maybe me, I'm not sure. It looks like very similar to what I'm writing now. Character dot use digit of abbr dot char at bb. Okay, if it's a digit, then do this thing. And another option is, if it's not digit, if it's neither equal, then we can just return it as false then and there. And then if we come out of this after comparing everything, all I need to do is basically both the length, both of the indexes are its length. So yeah, so I'll just return abbr index is equal to abbr dot length, and word index is equal to word dot length. So both are at the end of the comparison. Like if we end one of the words and the one, like either abbreviation or the word index is run out and the other one did not, that means that one is a substring of the other one, and it's not exactly equal. Exactly, we are doing the same thing. Yeah, is equal to true or false. We don't need this. True or false, basically we can just return this. Yeah. And then here, if it's a digit, then how do we capture the digit? How do we capture the entire number? So basically, I'll just mark it as int current num is equal to, okay, current num, I'll start with 0, and then while character dot, first thing is, okay, I will check if abbreviation index is less than abbreviation dot length, and character dot is digit of abbr dot char at er abbreviation index. Okay, until then I'll keep iterating, and then I will have to increment the abbreviation index. And in the meanwhile, I need to calculate the current num. Current num is equal to current number char 10 plus, okay, plus abbreviations current character minus 0. I would do that. That would give it in the ASCII. If I do minus 0, that would give the current digit value. So if it was like 1 minus 0, that would be 1. And then, yeah, I'm just adding it to the unit place and then multiplying the rest of the number by 10 in order to add this to the unit place. So that should give me the current number value by the end of this one. And then what I can do is, okay, so abbreviation index is already, I'm incrementing it letter by letter, and as long as it's either digit or as long as it runs out of this one. And then what I'll do is I will increment the word index by as many, plus is equal to current num, like whatever the number that we saw. I think I might have done the same thing. Let's see, string builder temp. Okay, here I'm gathering it as a temp, and I'm in the string builder. So here I captured it as a number. Okay, so let me run this one. Okay, internationalization, it worked. And then case Apple A to E, it worked for the basic cases. Let's submit it and check. Okay, A1 B01, A1 B01. Okay, this is supposed to be false, but it returned true. Okay, so what I should do? Okay, 0 is kind of invalid in the digit here, like the first digit. Else if the character is digit and not equal to 0, what I can do is, and I can just mark it as character dot abbreviation dot caret abbreviation index not equal to 0, then only go on to do all these computations. Otherwise, I can just return false as well. So, okay, is digit. Okay, this is closing braces. Okay. ABBDE, and yeah, now it is returning false for this use case. As soon as we encountered 0, I'm not going into determine the entire number as 0 and 1, and I'm just returned it as one character skip here. But since it's a leading 0, that is invalid, and whenever there is a leading 0, I'm not going into that, I'm just returning it as false. Here, how I had handled it, I built a string, temp string, and then I was checking if the temp.char is 0. I was returning false, but I think the other way it is better. Like here also, I think what I can do is if character dot is digit, and then I could have checked this one there only. Then I could have saved on a lot of computation there. So I could just do this. I could just do this. Here. Yeah. Here, if I do this, then I don't have to compute all this and then determine it here. So I can just remove the statement. So now let me submit this and check. Okay, it worked, and the performance improved as well. Let me check the modifications I made in the other approach as well. That too should work. So there I was. Okay, there I was determining by building it as a string instead of this one, and then I have a system.out. So that's what taking some lot of the runtime here. So if that's not the case, let's try submitting it once again. Okay, this gives 96%, and the other one also gives 96, close to that one only. So whether we do figure out the number by string computation or mathematical computation, it's almost one and the same thing. Okay, so it looks same. Let's move on to the next one. It's a LeetCode easy question. So valid word abbreviation is done. Minimum remove to make valid parenthesis. Minimum remove to make valid parenthesis. So this is LeetCode question 1249, and it's a LeetCode medium problem. Minimum remove to make valid parenthesis. So given a string s of only this braces and lowercase English characters. Okay, your task is to remove the minimum number of parentheses. Okay, in any positions, so that the resulting parenthesis string is valid and return any valid string. Formally, a parenthesis string is valid if and only if it is an empty string, contains only lowercase letters, or it can be written as AB, A concatenated with B, where A and B are valid strings. Okay, it can be written as A, where A is a valid string. Let's check this one. Input is LeetCode. Okay, there's one open braces, 2 and 1, 0, and then -1. So okay, I need to remove one of this one. Output would be, okay, I just removed this one. So 1 open, 2 open, so -1, 1 open, -1, 0 open. So yeah, so this one became valid. So LeetCode would also be accepted. So here, instead of removing the last one, they have removed the other ones, one here and the other one. So even those things are accepted. It's just that total number of open braces should be equal to total number of the closed one. And then the same thing here. So this is imbalance because it begins with an imbalance only before any braces are open. it is closing it. So it is an empty string, contains only lowercase characters, then the string is valid. It can be written as AB, A concatenated with B, where A and B are valid strings. Okay. It can be written as A, where A is a valid string. Okay. Task is to remove the minimum number of parentheses so that the resulting parenthesis string is valid and return any string. Okay, got it. Here just parenthesis is given. An empty string is also valid. Okay, then since there's no open braces before closing braces, so I will just remove those things. So I need to remove all four of those. Here I need to definitely remove this closing braces because it was not prefixed by opening braces, and then we will keep the rest of the string as it is. Okay, so the approach I think we are following here is remove invalid closing braces. First thing is invalid closing braces. If we know that in the first iteration itself, we are just removing it. Otherwise, we are just removing the extra open braces. We wouldn't know that in the first iteration. For example, in this case, if in the example 2 here, so if we keep iterating from left to right, we know that this is invalid braces. So we can just remove it as and when we encounter it. But here, if we consider this case, we do not know any of this is going to be invalid or not. This is an open braces, one open braces, two open braces, and then one is balanced. So let's consider it as one open braces now. And then both are balanced now. So now there are 0 open braces. And then here, closing braces is leading by 1. So I need to remove one of these open braces. So whichever comes first, I can just remove one of that. So remove the extra open braces open. So I'm writing that logic to remove that extra open braces at the end. So let's see how the code works. String builder result, string builder, I have added string builder here, and then left, I'm starting from left and right, which are 0, 0. Remove the invalid characters. Okay. Current char, I'm just iterating through the entire string array. If the current char is the open braces, then left plus plus. Okay, this left and right are like the open braces. Left represents the open braces and right represents the closing braces. If current char is open braces, then left plus plus. Current char is closing braces, then right plus plus. Okay, right is greater than left, then right minus minus. If the right is greater than left, okay, what they are doing, if the right is greater than left, then okay, here they are checking if the right gets at the closing braces at any point is greater than the opening braces, then I'm just decrementing the closing braces count, and then I'm not appending it. Otherwise, if the right braces is not greater than the left braces, then I'm just directly appending it to the result dot append current characters. And then here, now I'm checking at the end if the left braces is greater than the right braces. If the open braces, number of open braces is greater than the closing braces, that means we need to remove the open braces. Int open braces is equal to left minus right. So extra open braces, this is what it means is extra open braces is left minus right. So index is equal to result dot length minus 1. Okay, from the end it's coming, and then while open braces is greater than 0 and index is greater than 0, from the end it's traversing. If result dot caret index is open braces, if we encounter an open braces at any of the index, then I'm just deleting that and reducing the difference here, and then index minus minus for that string. Okay, result to string. Okay, this makes sense. We can just code it up as well if we need some muscle memory to practice. So So first thing is, let's compute the result. String builder, new string builder, and then int open is equal to 0. So I didn't like the naming as left and right, so close is equal to 0. And then for char current and let's start to char array. So what should I do now? If current char is equal to this open braces, then I'm just implementing open plus plus else if current char is equal to this closing braces, then close plus plus. Okay, and at any point if close is greater than open, then don't do anything, just decrement the close value of close. Otherwise, append it to the result.append current char. So if in this case only I'm not appending the result, when the close is greater than open, then I'm not appending it to the result. That means basically I'm removing it from the result. Now at the end of this one, definitely the closing braces cannot be more than the open braces. Now all I need to handle is what if the number of open braces are more. If the number of open braces are more, if open is greater than close, then what should I do? That's what we are doing here. If left is greater than right, that means if open is greater than close, then I will traverse from right to left. So index is equal to s.length, and while index is greater than or equal to 0, I'll keep traversing index minus minus, and if s.char at index okay, instead of s, let's look into the result only. Result.length, and then it would be result.char at index, and then index minus minus if result.char at index is equal to open braces, then result.remove the current index, and then how many times we do it. So that is like, okay, extra open is equal to open minus close, and okay, let's do it like this also, and extra open is greater than 0, then keep doing this, and then once I remove it, let's decrement this one as well, extra open minus minus. Okay, this looks good to me. Return regular dot to string. Oh, okay, string builder doesn't have remove, probably delete. Okay, what's the method that I have used before? Result.caret index, result.delete caret. This is the method. Delete caret index. Okay, and yeah. result.delete caret. Okay, and then here greater than index greater than or equal to 0, delete caret. Result.caret is equal to open, then doing this one. Okay, yeah, -1. Index I was starting with this one. Okay, this looks good to me. Okay, let's remove this one. The current code has better variable names. Otherwise, I think the logic is almost one and the same. Okay, let's move on to the next problem now. So this one was easy as well. Okay, this was a LeetCode medium. That's surprising. Buildings with an ocean view. This is another next question. So this is LeetCode number 1762. Buildings with an ocean view. There are n buildings in a line. You are given an integer array heights of size n. Okay, that represents the heights of the buildings in the line. The ocean is to the right of the buildings. Okay, a building has an ocean view if the building can see the ocean without obstructions. Formally, a building has an ocean view if all the buildings to its right have smaller height. Result: return a list of indices, 0 indexed, of buildings that have an ocean view, sorted in increasing order. Makes sense. So here the explanation is, okay, here all the buildings, 4, 3, 2, 1. So except for this one, 2, because the buildings with a height 2 doesn't have an ocean view, because there is a building with height 3 in front of it. Like there is an ocean on the right side. Imagine an ocean on the right side. This building is right next to the ocean, so that would have a view. This building is taller than this building, so that has a view. This building uh, is blocked by this building with the height 3. So the building with height 2 doesn't have an ocean view. Building with height 4, that has an ocean view because this is taller than all the other buildings to its right. So 0, 2, 3, we haven't included 1. And then here in this case, it's in the decreasing order, and all the buildings has the ocean view. And here only the building with the first building, which is right next to the ocean, just has the view, and all the other buildings are smaller than this, so this building blocks the view for all the rest of the buildings. So how to determine it programmatically? So I have taken the result list, and current tallest right building. I am just maintaining the current tallest right building. That would be integer dot min value when I start it, and then I'm traversing from right to left. I'm started traversing from right to left. So heights dot length -1 and I greater than or equal to 0, I minus minus. And if height of I is greater than the current tallest right building, then I'm replacing that with the current tallest right building. Yeah, and then otherwise I'm just adding it to the result, and then I'm just reversing that list because they have asked us to return the buildings sorted in the increasing order. So here they had asked us to return the indexes of the building, so I'm just adding I here. Result dot string stream activate. Okay, integer dot int value dot to array. Okay, was it needed? It was in the int format. Okay. Oh, I need to convert it into array. Okay, makes sense. So let me see another way. Array dot. Okay, and I think this is the best way. I guess I think this gives the flexibility of having a dynamic sized array, because we don't know how many buildings is going to have the view. if I'm using the static array, then I have to initialize it with the size, so I don't want to have that, but the result should be in this format, so I'm just returning it in the format that is asked with result list.stream map to integer, okay, int value dot to array. Okay, so either we can do this or we can simply do int value and result list and keep going like this. Let's just initialize in result equal to new int result list dot size. So result dot index is equal to value. And how do we determine index? Let's initialize it into 0, and let's do index plus plus as in when we move along. Yeah, that should give what we want. Let's just comment the next statement result dot. If there are anybody who is fan of the stream APIs, then they can use this syntax. I just don't want to use this in a interview setup because not all the interviewers will be well versed with Java and specifically Java Stream APIs only. I want to keep it more readable to everybody, and I would appreciate it when I am conducting the interviews as well. When someone makes the code which is readable in a universal language, I think that's the best part. This one can be looked up in real time if we are coding using Java in our code base. This just shows that expertise. Okay, here let's see, let's check collection.reverse. This works, this should work. Okay, so this returned, I don't even have to reverse it if you ask me, because I can just keep traversing from the last and then add it. Like for example, for int index is equal to result list dot length -1, and then I greater than or equal to 0, and then I minus minus, and then what we can do is result list dot get I. This should work too. Okay, instead of length, it should be size. Yeah, this works. So we didn't have to iterate twice. For reversing, it would have iterated once, so we just reduce one more iteration there. Let's remove this one also. Yeah, and I'm not liking this variable name for some reason. Current tallest right building. Or blocking building height. Better. Blocking height for now. Blocking height is min value when we start this one, and then I keep updating the blocking height. Okay, yeah, looks better. Let's move on to the next problem now. This is LeetCode medium. Okay, can't believe it's a medium. It looks like LeetCode easy. Okay, next one is basic calculator. I think we came to the actual medium now. And if I refresh this for the 30 days, okay. For the 30 days, there are 189 problems. Wow. Okay, and we solved 4. So let's get to the next one. Int calculator 2, given a string s which represents an expression, evaluate this expression and return its value. Okay, 3 plus 2 star 2. Okay, the integer division should truncate towards 0. You may assume that the given expression is always valid. All the intermediate results will be in the range. Okay, got it. You're not allowed to use any built-in functions which evaluate strings as mathematical expressions such as eval. Okay. Okay, so here there we are using in this approach a stack where, okay, if string is null or empty, return 0. That's a base case. If not, I'm just getting the string.length. Current number is 0 and current operation is plus. Why current operation is plus? Let's see. And then I have an operand stack. Operand is basically these digits. The operands are moved to the stack. So for int I is equal to 0, I less than length. Okay. Current character is equal to s dot caret I. Okay. And if character is a digit, then current char is equal to current number. Okay, if current number plus is equal to current number star 10 plus current char minus. Okay. Okay, I'm computing current number. Okay, it can be like 35 plus 5 as well, like rather than the single digit. So let me see if there can be something like that. So here if it is 35 plus 5 divided by 2, then that should work as well. Okay, 35 plus 5, 5 by 2 is 2, so that would be evaluated first, and then 35 plus 2 is 37. Great. So what we can do in order to arrive at that, so determining the current number. Current number, nice. I have initialized the current number as 0 and just computing that as long as there is the value in the current number. I'm just computing that value. I have used the logic of ASCII numerals or ASCII characters. So any digit, so I'm checking if the character is a digit. If it's a digit, current char minus 0 would give the current digit. So I'm just adding that to the unit place, and the current number I'm multiplying it by 10. And if it's not a digit, if current character is not a digit, and if it's not a white space, okay, there can be white space clearly here I have given, and if it's not a white space, ri is equal to length minus 1. Okay. Okay, I'm not sure about why this condition I have added. Let's look into that. So if it's not a digit and if it's not a white space, then I'm checking if the current operation is equal to minus. How do I know current operation? Current operation is equal to plus. That's the initialized version. And then current operation is equal to current number star minus 1. Okay, current operation is set to 1, like which is positive in the beginning. And then if the current operation is minus, when it will become minus, that's what I'm looking into. If, okay, current operation, I'm setting it to current character. So that's when it will become, it could become a negative number or a negative value. Okay, if let's say if the first character itself was negative, then I'm just changing the current operation as negative, and then it will accumulate a number, and then once that is done, I'm just performing the current operation. And okay, If the current operation is minus, then current number start -1. If it is plus, then just operand stack dot append current number. Or else if the current operation is a multiplication operation, then operand stack dot push. If it's a multiplication operation, then I should do current number star pop. Okay, current number is already computed, and current operation is okay. Current operation is nothing but the previous operation. So whatever we have set before this one. So if I is equal to length -1, that means we need to perform the operation anyway. That's why we are checking for this one. Like at the last character, we need to perform the operation of the previously determined current operation. So yeah, this should be like a yeah, current operation sounds good, like a previously determined current operation. Like why we are doing this. Let's say I'm traversing from left to right like this. Like in this example, 3 came and I just added it to a stack here. Okay, let me write it here, not anywhere. Okay, I have my stack operand stack, and then I have the current operation, which is the plus, and current stack looks like nothing, as of now nothing. And then I came across 3. It was nothing, just a number. If it's a digit, then I will, okay, there is a current number as well. Let me take it as current number is equal to 0. So what I'll do is current number start and plus this one, try to convert that. So 3 will become 3, will be 3 only. Okay, and next thing is plus. So once I encounter plus, this doesn't satisfy. So here this can be an else condition, else if, right? Okay, okay, it can't be else if. Why? Can it be current char can be a digit and not non-digit, or okay, even if it's a digit also, if it's the length, then I need to perform like here. Even if it's a digit, if I do just else if, it won't perform the operation after the last bit here. So it's important to have this in the as a if condition, separate if condition. Okay, let's do this one. Let's run through this example. Current operations, like after the first character, current number became 3 and plus remained plus, and then another plus came. So what did I do here? Now current operation is plus, current operation is plus, I checked, and then I need to push the current number to that one, that stack. So I push the current number to that stack, and then current operation became current char, which is plus, and current number became 0. Current number I modified it as 0, and then after plus, now it is another digit 2, and then current number became 2 here. Current number became 2, and nothing, this one doesn't satisfy. I'll just come out of this, and then next after 2 star came, so this one doesn't satisfy, and it will come inside this loop if the current operation is actually still a plus, because the previous one was a plus. So it will just add that 2 or plus 2 into the stack. So I just added plus 2 into the stack, and then our current operation is current char. Current char is star, so current operation became star, and then current number became 0 as it is set by here, line number 34. And next character 2. So now 2 came here, it's a digit, so current number became 2. Current number became 2, and then we come out of this one, and then it is checking for this condition. Here it is not a, if it's not a digit and if it's not a workspace, white space, or I is equal to length minus 1. So this condition satisfies. I is equal to length minus 1. 2 is I is equal to length minus 1. So what I'll do, I'll check the current operation. If the current operation is star, so what I'll do is operand stack dot push, operand stack dot pop got star current number. Current number is 2, and if I pop from the stack, this 2 would come. So 2 star 2 would be 4, and then I'll push it to the stack, that result as well. And then once I do this one, I push the result into the operand stack itself. Current operation is current char, and then current number is equal to 0. It is insignificant anyway. Current operation is current char, which doesn't have any value because we are out of that loop and we are not monitoring it, and it's 0. But that does not matter. And here I'm checking int computed result is equal to 0. Computed result, I'm just adding it until the operand stack is empty. So operand stack has 3 and 4, which is equal to 7. So computed result will be 7, which is returned here. Okay, makes sense. Yeah, it's a bit tricky. Tricky in the sense how to handle plus and how to handle star. Like it's not the same way. So whenever we encounter a digit, we are just adding it to the number. Let me just code it up, otherwise it might be memory, like muscle memory. Okay, if s dot I won't do anything different here, but basically we'll do the same thing. If s dot length is equal to 0, then just return it as null or return it as 0. Or s dot is empty in case there is an empty string. Okay, and then I'm checking here int current number. So here I'm looking into this logic, whatever we computed here. Current number we need, it is 0, and current operation, we can initialize it to something basic like plus, and then we have int, not int, stack of integer, and this would be operand stack. Okay, and then I will iterate through each character in the string. Current char to char array. Okay, and now what should we do? If character dot is digit current char, if current char is a digit, then basically update the value of the current number is equal to current number char 10 plus current digit value. Current digit value is that is current char minus 0. So with ASCII we will determine it, and then if character dot is not digit, I mean if it is the last character, then everything is sorted. If how would we determine that if it's the last character or not? I think we are looping by index in order to determine that. Let's do the same thing. Let's loop with the index instead of this one, because we need to get hold of the indexes. Okay, and current char is equal to s dot char at index is I. Okay, so now have the same thing satisfies here. So here I need to check if I is equal to s dot length -1. I mean, if it's the last digit, then definitely it satisfies. I will perform the computation. Or I'm checking if it is neither a digit and nor a white space. Then it could be an operation or a symbol basically to perform an operation. So that's when I'll do if current char is equal to plus, then I will just do operand stack dot push current char. Okay, not current char, current number. Yeah, just push the current number if it's a plus. And I should not check for current char, it should be like current operation, because I'm checking for the previously stored operation. And if current operation is equal to minus, then operand stack push current number star -1. Else if current operation equal to multiplication, I mean if it's then what I'll do, operand stack dot push current number. Like how do I get the current number? Current number star operand stack dot pop, and I'm just pushing the resultant value into the operand stack again. If current operation if it's a division, then I will do something similar. Okay, so here current number is the latest value. It's not current number divided by this one, but it should be the opposite. So because this comes first in the order, operand like whatever is in the stack, and that one divided by current number. Yeah, that makes total sense. And then once I do that, current operation would be equal to current char, and I will set the current number is equal to 0. I mean, I will reset it once the operation is performed. And then we will come out of the loop here, and then while operand stack is empty, actually while it is not empty, then I will keep computing the result. Computed result. Computed result dot add, not computed result plus is equal to operand stack dot pop. Okay, I just copied it over from there, so this should be s.length okay, character dot it white space of is white space of current char. 322. Wow. 3 is 2, and then it never performed this operation. If I is equal to s dot length -1, then I wanted to get inside this one and if current operation is equal to star, okay, so when this came, I should have, okay, it should be like if it's not a digit, if the current carries not a digit, and if it's not a white space. So I have never set that value. So yeah, this looks good to me now. So I can just remove this part. It is kind of similar. So, and I'll leave this one. It's easier to make it understandable. Or I can just remove this. Let's leave it. Fine. Okay. So now we are done with the basic calculator. Now let's find the peak element. Before that, let's take a break. I think we looked into 3 plus 2, 5 problems as of now. So it's 9:45. Yeah, let's look into at least 10, 15 more. Let's increase the speed a little bit now after the break. Okay, let's start with the next problem. So we are done with the basic calculator. Let's get into find peak element, which is again a LeetCode medium problem. Okay, find peak element. A peak element is a LeetCode number 162. Find peak element. It's a LeetCode medium problem. A peak element is an element that is strictly greater than its neighbors. Given a zero indexed integer array nums, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. You may imagine nums of -1 is equal to nums of n is equal to minus infinity. Okay. Okay, so you may imagine that nums of -1 is equal to nums of n is equal to minus infinity. Okay, so on either side of the list, we can imagine that the value is minus infinity. In other words, an element is always considered to be strictly greater than a neighbor that is outside of the array. You must write an algorithm that runs in O of log n time. So here in this case, 1 is greater than its left neighbor, because left neighbor, if there is nothing, it's considered to be minus infinity, but its right neighbor is greater than 1. So this is not a peak element. 2, this is not a peak element as well, because 3 is greater than 2. And for 3, it is greater than its neighbor on either side. So we are returning the output as 2. And for this one, 2 can be a peak element, and then 6 can be a peak element. So your function can return either the index number 1, which is value 2, where the peak element is 2, or the index number 5, where the peak element is 6. Okay, got it. That makes sense. So what we are doing here is, okay, using the binary search iterative method and using the binary search recursive method here. Okay, why is that? Why they are using peak element or a binary search when the array is not even sorted? So how can we use binary search when the array is not sorted? Because if we traverse by looking into the elements one by one, then definitely we can find the peak element and then return its index. So that would be work in problem. But here what they are doing is left is 0 and right is nums dot length minus 1, while left is less than right. Mid is equal to, okay, middle element, and number of mid is greater than number of mid plus 1, then right is equal to mid. Okay, okay, if nums of mid is greater than nums of mid plus 1, if this one nums of mid, let's say this one is the nums of mid, if it is greater than nums of mid plus 1, then right is equal to mid. Okay, then I'm just looking to the right side of the element, otherwise I'm coming to the left side of the element. Okay, what's the logic behind this one? Let's try to understand it. We just found a random middle element, like, okay, like here in this case 3 is the mid element here. So now we are checking if nums of mid is greater than nums of mid plus 1. If nums of mid is greater than nums of mid plus 1, no, it is less than that. So right is equal to mid. So this became right. So here what we know for sure is, okay, this is less than its like number of mid plus 1. Okay, and then left is equal to, okay, and then I came back here, and then left, still left is less than right. Okay, left is 0 and right is 3 4 0 1 2 3. Okay, and then 3 by 2, which is 1. So I'm checking if this is greater than its right, then right becomes mid. So now, okay, so sorry, here in the first case nums of mid is greater than nums of mid plus 1. No, that was not true. So left became mid plus 1. So left became mid plus 1 means 5 became left and 4 is right as usual. And then again I checked here if left is less than right. Yes, left is less than right, and middle is left plus right divided by 2. So this is 0 1 2 3 4. So 4 plus 6 divided by 2, 10 by 2 5. So that would be this index. If the middle element is greater than mid plus 1, yes, middle element is greater than mid plus 1. So right becomes mid. So this becomes right now, and left remains with this one. And left value is 4 and right value is 5 now. So 4 plus 5, 9 divided by 2 is 4. So mid value is 4. So now we are checking if nums of mid is greater than nums of mid plus 1. No, that's not true. So left became mid plus 1. So left became mid plus 1. So this is itself is left and this itself is right now. So left is not less than right as of now because both are 5. I'm just returning left. Okay. Yeah. Need to understand the logic behind it, like how it works. Let's try to, rather than breaking our head over it or try to see the editorial, let's try to ask ChatGPT how it works. Explain. Solve it. Hit in. Log in. Okay. Let's read through this one. Great question. Let's break down the find peak element with an intuition for login solution. Okay, we know the problem. Brute force approach, we know. Iterate through the array for and check if the nums of I is greater than nums of I minus 1 and nums of I is greater than nums of I plus 1. This is easy. But since we want O of log n, we need a smarter way. Intuition for O of log n solution, we don't need to find the largest element, just any peak. The key observation, if nums of mid is greater than nums of mid plus 1, a peak lies on the left, including mid. Okay, what is this one? If the nums of mid is greater than nums of mid plus 1, a peak lies on the left, including mid. Okay, if nums of mid is less than nums of mid plus 1, a peak lies on the right. Why is this true? If nums of mid is greater than nums of mid plus 1, it means you are on a descending slope. Okay, there must be a peak on the left side. Could be the mid itself. Okay, it means you are on the descending slope. There must be a peak on the left side. Could be a mid itself. Could be mid itself. Okay, how do we know? If mid is greater than nums of mid plus 1, it means we are on a descending slope. Okay, in this example, let's say this one is the mid. If mid is greater than nums of mid plus 1, yes, it is greater than nums of mid plus 1. That means we are in the descending slope. There must be a peak on the left side. Okay, on its left side, including the mid. Since that is greater, not all the elements are less than this. Okay, this one is like, okay, this is the mid value and that is greater than its right element, mid plus 1. So we decided to look for the mid element on the left side of this. Why did we do that? If this one is greater than this, that means this could be a peak element, or there can be a peak element that lies on the left side of this. Okay, why we are so confident? Because on the left side, if the immediate left element itself is smaller than this, then this itself can be a peak. Otherwise, if the immediate left element is greater than this, that means, okay, a 4 came, 4 is greater than this, so which would be greater than this, and then we need to find some element which is smaller than this. Let's say if all of these are in the increasing order, like let's say if this was 4, 5 and 6, then there was no peak element. 4, 5, 6. Okay, if that was the case also, 6 is the peak element, right? If there was 6 that is greater than its right element, which is 5, and that is greater than its left element, which is minus infinity, from the assumption that we made. And here, why couldn't be a peak on the right side? Why did we ignore all of them? Because we know that half of the condition was satisfied on the left side, because this is, since the element is greater than its immediate right element, so half of the condition is satisfied. So even if there is an increasing slope on the left side of this one, we will find the peak on the left side, either somewhere in between, or the first element would be a peak, as peak in the worst case. If all of them are in the increasing order, we assume that the first element is greater than this one, its immediate right, and then we know that it's always greater than its borders. Basically, nums of -1 is considered to be minus infinity, and nums of n is considered to be minus infinity. That makes sense. Okay, because of the virtual minus infinity at both ends, you are guaranteed to have at least one peak. Makes sense. Why is this true? If nums of mid is greater than nums of mid plus 1, it means you are on a descending slope. There must be a peak on the left side. Could be the mid itself. If nums of mid is less than nums of mid plus 1, you are in an ascending slope. There must be a peak on the right side. You are on an ascending slope. Okay. That means there must be a peak on the right side. I mean, could be the next element to the mid itself can be the can be the mid element. So because it's the same logic here. Let's say if this was like a if this was the mid element that we found, and then if this is 5, 6, and 7 on top of on to the right of this one. So when it is 5, if we find any elements onto its right which is smaller than this, that means we would have found a peak here. Like if it was 5 and if it is 2, then that's it, that's a mid. Or if it is 5 and if its immediate neighbor is something greater than this, like 7, then this is not a mid. But any time it decrements, it is a mid. If it's 7, then if it's a 5 or something, then this one's a mid. In the worst case, if it's all of them are in increasing order, if it's 4, 5, 6, 7, then 7 is the peak here because it's greater than 6, its immediate left element, and also it's greater than its right element, which is minus infinity. So we are guaranteed to find a solution there. That's what the intuition behind this approach, and we do that in log n value, log n time. Let's go back to our problem. So yeah, so let's this is a like simple enough binary search approach, but I wouldn't know if it's a binary binary search if I had not seen the solution or the approach here. It's not intuitive, very intuitive to come up with the solution if you haven't seen this before. So int left is equal to 0, int right is equal to nums.length. Okay, nums.length minus 1, and then while left is less than right, we need to keep doing this, and then if int mid is equal to left plus right divided by 2. When we think something is too easy, it's easy to ignore it and get stuck with the solution for that. So let's understand and practice it rather than feeling sorry later. If left is greater than, okay, while left is less than right, okay, we found the mid. If nums of mid is greater than nums of mid plus 1, that means the peak is on the left side of it, including the mid. So I'll mark right as mid. If that's not the case, then I'll mark left as mid plus 1. So mid plus 1 can be the peak at that point. And then once this condition is not satisfied, I'll just return left. Okay, it works. Same solution. Okay, let's look into the next problem now. Lowest common ancestor of a binary tree. Okay, lowest common ancestor of a binary tree, 3. Okay, in this one, given two nodes of a binary tree, P and Q, return their lowest common ancestor, LCA. Each node will have a reference to its parent node. The definition for node is below. Okay, class node public int value, public node left, public node right, and public node parent. Okay, according to the definition of lowest common ancestor on Wikipedia, the lowest common ancestor of two nodes P and Q in a tree T is the lowest node that has both P and Q as descendants, where we allow a node to be descendant of itself. Okay. Okay, the tree structure itself includes the parent reference as well, reference to the parent here. So we have value right, left, right, and then a reference to the parent also. let's see. Here, according to the least common, okay, two nodes P and Q in a tree. T is the lowest node that has both. Okay, when we have the reference to the parent, what we can do is we can just traverse the path to its to the root from the current node, and then if there is a match, we can keep adding the node of the parent to a set, and if there is a match of any node, the first match itself would be the lowest common ancestor. That's easy, I think. Okay, so what they have done, node parent is equal to P, parent Q, parent P is equal to P, parent Q is equal to Q. Okay, while parent P not is equal to parent Q, parent P is equal to parent P not equal to null. Okay, this is like a fast node and the slow node in the linked list, um, like that. So this is one way. Whenever they intersect and we are not using any additional space into this one, we just keep traversing by circling. If the parent P dot parent, like we just keep checking parent P and going up in the hierarchy, and when the parent P hits null, then we are switching to the value of parent P as Q, and the same way when parent Q, like we are switching to P when we hit the null. So we keep doing that there. So that is one way. If we need to use additional space, then it's easy. We can just use the hash set and do the same thing. Okay, have they asked if it has to be in the O1 space complexity? Okay, no, they haven't. So I would say the more intuitive or the most intuitive approach should be using a hash set or something and use it, but that would be WOF in space complexity. That could be WOF in space complexity. This is much better in terms of space complexity, but runtime would be the same in both of those. Um, Actually, the best runtime would be the other approach, because we will find it in the minimum number of iterations only. We don't have to rotate until we meet there. So yeah, so yeah, it can take multiple rotations if we have to meet at a single point. But in the other approach, in the worst case, we can meet in O of n rotation, O of n traversal, and O of t traversal and O of t traversal. So O of 2D traversal at the worst case. So okay, so let's not try to code that approach. It's a simple enough. We just create a hash set, uh, and we keep adding everything in that hierarchical path, and whenever we meet, whenever the first element that is common across both of those, we will just return that node. Parent P, return parent P, okay. While parent P not equal to parent Q, we just keep rotating. Okay, got it. This is a bit tricky. to come up with the solution on the spot. Okay, find peak element, lowest common ancestor 3, and diameter of tree. Okay, next 3 we have easy problem. Let's take a quick break and then let's get back. Okay, let's start with the next one. Kth largest element in the array. Okay, so here did the frequency kind of shifted during this stream? Not sure. Yeah, we haven't solved this one as well. Diameter of the binary tree. Let's look into that next. But now kth largest element in the array. So here, kth largest element in an array. Given an integer array nums and an integer k, return the kth largest element in an array. Note that it is the kth largest element in the sorted order, not the kth distinct element. Can you solve it without sorting? I think one easier way is if we sort it, it will be n log n, the best case. Other way we can do it as n log k by using a priority queue. Yeah, because we can just keep k elements in the priority queue, and if it exceeds k elements, then we will just reduce the size of it, and we'll keep the top k elements in the priority queue all the time. Like when we iterate through this array, we keep 3, we keep 2, so top 2 elements when we iterated 2 elements, and then we came across 1. This is not greater than the peak, and okay, it can be a min heap instead of a max heap, uh, so that okay, if there is something less than this, then we won't add it into the heap. Okay, so 1 we won't add it to the heap, we compare it with the peak of this element. Peak is 2 in the min heap, so we won't add 1. 5 we will add, we compare it with the peak, we will add, and then the size of the priority queue becomes greater than k, then we will remove the peak, which is 2, we will remove the 2, so now 3 and 5 are in the priority queue and 3 is the peak, and this is 6 is greater than peak. Again we'll add 6, so 5 and 6 will be in the heap, and we will remove 3, and then 4 we won't add it to the heap because peak 5 is greater than 4. So now the kth element is like, okay, we have 2 element and the second greater element is 5, we will return just the peak of the priority queue. That looks good. Find the kth largest. So here, yeah, this is the priority queue solution. O of n log k and space is O of k. I just defined a min heap and iterating through that, and if the size of the min heap is greater than k, I'm just removing it from the min heap and I'm returning the min heap dot peak. And then here there are other approaches. Code using quick select times O of n on average, but O of n square in the worst case. So this isn't any better for all the cases, but okay, something to keep track of or something that we can learn. And code using counting sort. Counting sort is like m is max, min, n is length of, okay, time is O of n plus m, and space is O of m. Okay, what is n and m? Okay, counting sort is integer dot max value, min is integer dot max value, and max is integer dot min value. Okay, and then we figured out the min and max value in the nums, and then we created the buckets, and then we keep adding it to that bucket. Okay, num minus min plus plus. Okay, okay, got it. So we are just adding it into that bucket, and int remaining is equal to k for int I is equal to bucket dot length minus 1 if I greater than or equal to 0, remaining minus are equal to bucket of I. Okay, remaining minus or equal to bucket of I. So in the bucket, all the values will be 0 initially. So if there are any additional values, then that many frequent elements already appeared in that. So yeah, so it makes sense. We can just keep adding to that one. Okay, this will take care of the duplicate elements also. What about the priority queue? In the priority queue, are we taking care of the duplicate elements? Kth largest element. So output is 4 here, and fourth largest element, because there are 2 5s. Okay, 6 and 2 5s and then 4. So the fourth largest element is 4. So here in the priority queue also we will be adding the duplicates, and it will hold the duplicates. So we will end up in the same way. And this bucket sort also um, supports the duplicates in the same way. Let's see the quick select. I won't bother to memorize it or anything. Quick select is something like quick search, quick sort. List input, okay, new array list, and I'm just adding it to the dynamic array input, and then I'm running a method called quick select, and I'm passing k and here. Okay, in pivot index is equal to new. Okay, in this one I think the logic is sorting only the k elements on the right, rather than in the quick sort we try to sort all the elements. Here we try to sort only the we try to put all the elements greater than k elements into the right, and all the elements lesser than k elements into the left. Basically, that's how we do the minimum work to find the output that we need, because we do not care about all the elements which doesn't matter are sorted or not. Okay, pivot index is equal to found a random index, and pivot is equal to nums.get pivot index. Okay, greater than pivot, then we created a new array list, and less than pivot we created a new array list, and equal to pivot we have another array list. And for all the elements in nums, okay, what we did, if num is greater than pivot, we just add it to the corresponding buckets here. And then if k is less than greater than pivot dot size, then return quick select of greater than pivot comma k. If k is less than, okay, if greater than pivot itself has more values than what we need, more values than k elements, then we will try to just run the quick select on that array list again. If not, if greater than pivot dot size plus equal to pivot size is less than k, then return quick select of less than pivot comma k minus greater than pivot size. Okay, then we need to figure out like how many elements that we need to take from this one. Okay, let's say if the greater than pivot on and equal to pivot, those two combined also cannot make as many number as k, then what we will do is we will reduce the number of k. Instead of reducing the sample size, we will reduce the k that we are looking for. Reduced by how much? Reduced by the size of the greater than element, and then the equal to element, and then we will look into the less than elements for the k minus that many elements. and then we will return the pivot. Like if it was not greater than this one, that means equal to pivot would be the answer. Like if either of those condition doesn't satisfy, then we will have a pivot here. Okay, that makes sense. Okay, buckets are this simple enough. We just create those many buckets, but the space complexity wise, it is two extra space if it's a sparse matrix containing numbers from a wide range. Quick select seems to be usually usually the best case, but if it's the last element, if we keep sorting until the last element, it can go up to O of n square. I like the priority queue approach. Um, yeah, for this also space complexity is O of n, and if priority queue space complexity is O of k, and O of n log k, and that is also good enough. Okay. Yeah, if we know all three approaches, it doesn't hurt. Okay, quick select, we are just arranging it into three different buckets: greater than pivot, less than pivot, and equal to pivot. If the greater than pivot has more elements than k, then we keep searching in the greater than pivot itself. Or else if greater than pivot and equal to pivot both combined doesn't have as many elements as k, then we will reduce the search space. We will reduce the k by as many number in greater than pivot and less than pivot, and we will try to find the top k minus as many elements. And then if both the condition doesn't satisfy, then we will just return the um, pivot element as the equal to pivot, whatever is there. So yeah, that makes sense. Let's submit this one as well once. Okay, like this approach, quick select summary for some reason, because it's not this kind of exclusive. This feels exclusive. Not everybody would know it. Okay, so we solved 7 problems. So next one is diameter of a binary tree. So given a root of a binary system, return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. Length of the diameter is the length of the diameter. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. Okay. The length of the path between two nodes is represented by the number of edges between them. Got it. So here I think it's 3. 1, 2, 3, between 4 and 3. Okay. Put 1. 3 is the length of between 4 to 1, 3. Okay. Or 5 to 1, 3. Okay. And it's a LeetCode easy problem. LeetCode 543, diameter of a tree. And how are they determining it? So left path is longest path recursive node dot left. Right path is longest path recursive node dot right. If left path plus right path is greater than the diameter, then diameter is equal to left path plus right path. Okay. Okay, so I'm calculating the diameter from each of the node recursively. So from the node, I'm checking like if the calculate the longest path recursive from node dot left, and that would return whatever the maximum path of the left path and the right path and add 1 to that one. And then at the same time, if I have some intermediate diameter, I'm just updating it here. Left path plus right path is greater than diameter. Okay, how it would work? Let's see. I just initialized an instance variable called diameter in this class, and I initialized it to 0. And then longest path recursive, I am traversing here. If the node is null, then I'm just returning 0. And in the left path, I'm determining longest path recursive node.left. So I came here, and then in the right path, okay, and then it will determine again, it will go to determine the left path, so that will come here, and then it will try to determine the left path, which is 0, it will return 0. Then I'm coming here, ignore this statement for now. I'm returning mat.max of left path and right path plus 1. So the left path of this node 4 is 0, right path of this node 4 is 0, plus 1, I'm returning it as 1. And then for here, uh, 5 also returns 1 in the same way. And for this node, the left path returned 1, right path returned 1. So math.max of left path and right path is 1 plus 1, 2. It will return 2. And this will return, for this one, the left path returned 2. The right path would return 1 because left and right was 0. 0 plus 1, it will return it as 1. So 1 plus 1 and 2. So math.max of 1 and 2 is 2. 2 plus 1, this will return it as 3 to its parent, but there's nothing in that. So this will return it as 3. So I'm not returning the same value that is returned by the longest path recursive of root here. But what I'm doing is I'm returning the diameter. Where does this gets updated? So here the diameter gets updated when left path right plus right path is greater than the diameter. Then diameter is equal to left path plus right path. So diameter was, so when I came to this node, I have to compute the diameter. I'm not just computing what is left plus left, what is the greatest in the left or right plus 1. I did that because for this case, if I have to consider, like I can't come by a path like left plus right and then plus 1 to this one. Like whenever I'm considering in its parent, I can just consider one path from here, like either the left from 2 or the right from 2, not both of those. So I was returning mat.max of left path or right path plus 1. But if I'm computing the maximum path here only, maximum diameter here only, then it will be like left path plus right path plus 1. Sorry, plus 1 won't be the case here because the edges are just left path and right path. So uh, if left path and right path is greater than the diameter, then I'm just updating the diameter. That's what happened here. When I came to 1, the left path was 2 and right path was 1. So if that is greater than the diameter itself, so 2 plus 1 is equal to 3. That was the diameter value, and I returned that one. Okay, and if that's the case, like if this one also had diameter 2, like if there was a child to this node with 3, then this would have returned 2 as well. So 2 plus 2, the value would have been 4, whereas if we can compute it using math.max of left path comma right path plus 1, that would have returned 3. But the diameter, I would have updated it as 4 here if this had a child. It should be good. Let's move on to the next problem now. Okay, so now lowest common ancestor of binary tree 3. I think we looked into that. We just did not. Okay, parent, we just did not execute it or submitted it. That's why it's not marked. Okay, so that is done. Now valid palindrome 2. Okay, LeetCode 680 valid palindrome 2. This is a LeetCode easy problem. Given a string s, return true if the s can be a palindrome after deleting at most one character from it. Okay, so what is a palindrome? If a string or a number reads the same from the front and back, that's a palindrome. And now they're asking return true if s can be palindrome after deleting at most one character. I mean, it can be palindrome as it is, or by deleting one character, if it's a palindrome, then return true. So ABA, I keep an index from the beginning and keep an index from the end. I keep comparing the elements. If it's equal, then I keep shrinking my search space. If it's not equal, then what I should do? Like, okay, A and A. Now those two are equal. I'll need to compute this BC, and then in this BC, if it is not equal, then I'll leave one of this character and start from here. If the C is a palindrome, C itself is a palindrome, or I'll leave this parameter and then check here. If B itself is a palindrome, yes, single letter strings are always a palindrome, so it returns it as true. So either way, ABA is a palindrome or ACA is also a palindrome, so it is returning it as a palindrome. And here in this case, okay, A is not equal to C. So now what I'll check is either I'll remove this A and then check if BC is a palindrome. No. And then I'll check here. I'll remove C and I'll check if AB is a palindrome. No. Again, I'll return those, since those two return false, I'll return entire thing as false. So I'm initializing left is equal to 0, right is s dot length minus 1. While left is less than right, I keep going. And then if s dot char at left is not equal to s dot char at right, then I'm checking is palindrome of s dot left plus 1 comma right. So left I incremented by ignoring one of the character, right, or is palindrome of left right minus 1. I ignored one in the right. If either of them is a palindrome, then I'm returning it as true. I'll just return it as true. If either of them are not a palindrome, I'm returning it as false here. If it was equal, if we don't find any unequal characters, then we keep incrementing left and we keep decrementing right. And then if everything satisfies here, if it's a palindrome without deleting anything, then we just return it as true. And here in this is palindrome method, we are just checking it in a routine way. If like all the characters should be equal to on either side, then only we are returning it as a palindrome. Okay, so that should be good. Let's submit it. Okay, and then merge sorted array. Okay, you are given two integer arrays nums1 and nums2. You are given two integer arrays nums1 and nums2 sorted in non-decreasing order. Sorted in non-decreasing order means sorted in increasing order, and two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order. Okay, the final sorted array should be returned by the function, but instead the final sorted array should not be returned by the function, but instead be stored inside array nums1. To accommodate this, nums1 has a length m plus n, where the first m elements denote the elements that should be merged and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. So okay, so the length is given m and n. Okay, and we can compare like m is 3 and n is 3. Here in both the cases m and n is 3. So 3 minus 1 index 2 and 3 minus 1 index 2. So we will compare these indexes and check the greater element out of these indexes, and then keep adding it from the end of this index. So out of these two, the greater element is 6. Okay, we added 6 here, and then we reduce the index of this one, nums2 index to or index 2 to this one. Now it is pointing to 5. 5 and 3, the greater element is 5. We added 5 into this index, and then we reduce the index to this one. And then 2 and 3, okay, the greater element is 3 here. So added 3 into this index and then reduce the index here. And then 2 and 2, I can add either of those. So added a 2 here and then reduce the index of this one to this. So 1 and 2, I added 2 and then override it by 2, and then next one is 1, remaining is 1. I just add it, and it will just remain. I don't have to do anything if nums1 index are still incomplete. If nums2 index are incomplete, I can just add all the elements. So that's easy. If index 1 is equal to m minus 1 and index 2 is equal to n minus 1, current index is equal to nums dot length minus 1, while index 1 is greater than or equal to 0 and index 2 is greater than or equal to 0. If nums1 of index 1 is greater than nums2 of index 2, nums1 of current index is equal to nums1 of index 1. Nums1 of current index is equal to nums1 of index. Okay, current index is indicating the output index, and then index 1 indicates index 1, index 2 indicates the index 2 in the nums2. Okay, we are just decrementing it, current index and nums1 of current index minus minus is equal to, okay, while index 2 is greater than or equal to 0, I'm just assigning it to all the values in nums1. Makes sense. So I'll just submit this. Okay, so now merge sorted array is done. Nested list weight sum. Nested list weight sum. Let's take a couple of minutes break and then let's get back to that one. So please give me a heads up if you are in the chat and or if you're in the stream, and feel free to ask me any question if you are confused about any of the approaches spoken in that stream. I'll be back in 10 minutes for this one. Okay, I think you didn't hear. So lead code number 339, nested list weight sum. It's a lead code medium problem. Here you are given a nested list of integers. Nested list, each element is either an integer or a list whose elements may also be an integer or other list. The depth of an integer is the number of lists that it is inside of. For example, the nested list 1, 2, 2, this one has the integers value set to its depth. Like this one is inside only one list, the external list, and this one twos, these are inside two lists. Like this is the external list and this is another list, and the three, it's inside this list which is inside this parent list which is inside the external most list. So this is the depth of this one is 3. Return the sum of each integer nested list multiplied by its depth. So what we are doing is, at the root level, the depth is 1 since it is a list passed in the root level itself, and I'm trying to apply depth first search in that. So I have the depth integer sum is equal to 0. I'm initialized to 0, and then if the item is an integer, then I'm doing sum plus is equal to nested item dot integer char depth was passed as 1 in the beginning, and then if it's a list instead of an integer, dfs of nested item dot get list, and then I'm incrementing the depth by 1, and then that would return whatever that would return. I'm adding it to the sum. Finally, I'm returning the sum of all the elements multiplied by its depth. Okay, so let's move on to the next problem now. Okay, so merge sorted array is done. Nested list weight sum is done. Subarray sum equals k. Let's look into this one. Subarray sum equals k. Given an array of integers nums and integer k, return the total number of subarrays whose sum equals to k. A subarray is a contiguous non-empty sequence of elements within an array. Okay, 1, 1, 1. How many subarrays equals? Given an array of integers nums and an integer k, return the total number of subarrays whose sum equals to k. Okay, 1, 1, 2 and 1, 1. Okay, and these are not sorted, or none of those characteristics are given here. 1 plus 2, 3, and just 3 is 3. Okay, how do we go about this one? Let's see. Using additional space for storing past prefix sums in a map. So here, times O of n and space is O of n. So we have a variable called prefix sum which is 0, and subarray sum count is 0. Subarray sum count, I mean how many results are got, results have been computed till now, is 0. Now let's have a map. Pass prefix sums is equal to new hash map. Pass prefix sums dot put 0, 1. Pass prefix sums of 0, 1. Okay, so prefix sums of 0 is 1. Int num prefix sum plus is equal to num. Okay, added whatever the value in the integer, first value, into the prefix sum, and then pass prefix sums dot contains key prefix sum minus k contains key pass prefix sums dot contains key prefix sum minus k. Okay, subarray sum count plus is equal to pass prefix sums dot get prefix sum minus k. Pass prefix sums dot put prefix sum dot pass prefix sums dot get our default prefix sum, comma 0 plus 1. Okay, let's run an example for this one. For example, 1, 2, 3. Okay. If we come to this one, prefix sum is initialized to 0, and then subarray sum count is initialized to 0 as well. And then past prefix sums is a map, and then yeah, iterating through the numbers. So first number is 1. So prefix sum is equal to plus is equal to number, so prefix sum would become 1. And then past prefix sum, it does not contain any key, so it won't execute this one. Past prefix sum start put prefix sum of get our default plus 1. So prefix sum is 1, and then it will add 1 to this one. And then okay, and the next element is 2. So now we came here to prefix sum is equal to 2, prefix sum plus is equal to 2. So prefix sum was 1, so now it became 3. And past prefix sum dot contains prefix sum minus k. What is the value of k? K is equal to 3. So prefix sum minus 3, 0, comma 0. Okay, we have initialized prefix sum dot put 0, comma 1. For 0, it should be 1. That was initialized. Okay, so past prefix sum contains prefix sum minus k, 3, comma 3 minus 3, 0. So subarray sum count plus is equal to past prefix sum start prefix sum minus k. Okay, so subarray sum count is incremented by 1 because past prefix sum dot get of 0 is 1. So this will become 1. Okay, and now past prefix sum dot put prefix sum is 3, and past prefix sum dot get or default, okay, prefix sum of 0, comma 1. So I will add 3 and 1 here, 3 and 1 as key and value. And then now the next term 2, next term is 3. Okay, I think I came to 3 only. 1 plus 2, 3. No, now it is 3. So 3 is the next term. So prefix sum plus is equal to num. So prefix sum would become 6. And then here, if past prefix sum contains prefix sum minus k, prefix sum is 6, 6 minus 3, 3. Yes, it contains 3. So now I'm adding subarray count is equal to past prefix sum dot get of prefix sum minus k. Yes, okay. So prefix sum get of prefix sum minus k is 1. So subarray count will become 2. And prefix sum dot put, I will add 6, for which 1 is the count. Okay, and then I will just return subarray sum count, which is 2, and that is the answer output here. And let's see other approaches as well. O of n square time and space is O of 1. Using additional space for storing. Okay. Let's ask ChatGPT as well, just to analyze this one. Okay, it says naive approaches brute force, which takes O of n square. Basically loop over all the subarrays, calculate the sum of each, and count if the sum is equal to k. And then another one is prefix sum plus hash map. Prefix sum helps us calculate the sums of the subarrays quickly. If sum of I is the prefix sum till index I, then sum of subarray of j plus 1 to I is equal to sum of I minus sum of j. Okay, what is this one? Sum of subarray of j plus 1 to I is equal to sum of I minus sum of j. Okay. If sum of I minus sum of j is equal to k, it means we found a subarray that sums to k. Okay, how hash map helps? We store the count of prefix sums as we iterate. At each step, check if the prefix sum minus k is in hash map. If yes, it means there are some subarrays ending at the current index with some k, and the count of the prefix sum minus k to result. Add the count of the prefix sum minus k to the result. Okay, that makes sense. Okay, I think now I can implement it without even looking into the result here. Let's see. So the prefix sum is equal to 0. Let's initialize that int. So the result is equal to 0 as result. And then I need to iterate through each of that. Before that, I will add a map to store the prefix sums. Integer, integer. Okay, and then I'm iterating through each elements in the array. If the prefix map dot contains key, if that contains key num, then all I need to do is if that contains the key num minus k, not num minus k, like for example, okay, and also I need to initialize this. For 0, I will be adding it as combination 1 prefix from map dot put. For 0, the prefix from map can be 1. So I mean prefix sum is 0 even before starting any loops. For an empty array also, there is one combination without considering any of those. So num minus k, prefix sum minus k, not num minus k, the current prefix sum minus k. So what's the current prefix sum? Current prefix sum would be equal to whatever the prefix sum plus num. So current prefix sum minus k, if that already exists in the hash map, then that means I can increment the result. Plus is equal to prefix sum map dot get prefix sum minus k. And if not, then all I need to do is I need to add this as a newer prefix sum. Prefix sum map dot put. What would I do? Put prefix sum comma. I'll do this one again. prefix some dot map dot get or default pip. Prefix some comma 0 and +1. Return the result at the end. Okay, this is accepted. This looks good. So let's move on to the next problem now. Simplify path. So in the simplify path, you are given an absolute path for a Unix style systems, which always begins with a slash. Your task is to transform this absolute path into its simplified canonical path. The rules of Unix style file system are as follows. A single period represents a current directory, double period means represents the previous or parent directory. Multiple consecutive slashes as double slash or triple are treated as a single slash, and then any sequence of periods that does not match the rules above should be treated as a valid directory or a file name. Okay, for example, triple dot or 4 dots are valid directory or file names. The simplified canonical path should follow these rules. The path must start with a single slash. Directories within the path must be separated by exactly one slash. The path must not end with the slash unless it is a root directory. The path must not have any single or double periods. The path must not have a single or double periods and used to denote current or parent directories. Return the simplified canonical path. Okay, here home and ending slash is removed and just returned it as a home. The trailing slash should be removed, and home, this one, the trailing slash should be removed, and double slash means a single slash here. Okay, and here this dot means it's a previous directory, so it could be like home users a double period refers to the directory upper level, the parent directory. So it is currently in the document, and the parent of the document is user. Inside user there is pictures, so documents and pictures are in the same level. So home user document pictures. Okay, so it goes to parent directory, which is user, and then pictures. Okay, input. Okay, now it is home directory again. Going one level up from the root directory is not possible. Here 3 dots means that's a valid directory name, and then A, but it is going to the parent directory, so it just remains with 3 dots directory, and then B, and then C, but C again it's going to parent, so it comes to B, and then D, and then this means current directory, nothing. So 3 dots is a valid name for a directory in this problem. Okay, simplify path, directory stack. Okay, we have used a stack for this problem, and then splitting the components of the directory path by a slash here, and after that is done, I'm iterating through each of the components or each of the path components. Okay, if the directory dot equals just a dot, then, or if the directory is empty, then do nothing, just continue. If the directory dot equals double dots, then that means just go up one level, so just remove the previous directories also, previous directory also. If not of directory stacks dot is empty, directory stack dot pop, so just remove the previous one as well. Else Otherwise, just add it to the directory stack dot add directory, and then string builder simplifies path, new string builder. Okay, directory stack simplified path dot append, simplified path dot append directory. Okay, return simplified path dot length greater than 0, then simplified path dot to string. Okay, if this stack had anything, then just convert it into a string and return it, or else return a slash. Okay, here I haven't used the stack properties, but iterated in the same order of addition. Here only I have used the stack properties. Let's try to comment it out and code it up once. String directories, and then we will path dot split based on slash, and then iterate through each of those components. Okay, once that is done, I need a string builder as well. String builder. I will name it as path builder. Okay, and here, if the directory is equal to a single dot, or if the directory name is empty, then do nothing. If the directory name dot equals double dot, then just pop out the previous element from this directory stack dot pop. If not, it's all the valid directory name. That means just push it to the stack. So if it is equal and directories dot, I'm just checking if the stack is also not empty. Okay, once that is done, I'll have all the elements in that directories, and then I will have to iterate through that jack for directory directories jack path builder dot append, and then path builder append the directory name. Okay, once everything is done, let's return path builder dot if it is empty, then just return slash. If not, return the path builder dot toString. Should be directory jack. Okay, so in this case, okay, here this condition, I can just check it here. If it is empty, then only pop. Otherwise, do nothing basically. Yeah. Yeah, let's move on to the next one. Lowest common ancestor in a binary tree. So lowest common ancestor in a binary tree, we had defined it. How did we solve this problem? This is a LeetCode medium. So how are we solving this one? Here, the difference between the lowest common ancestor that we solved before is the node structure doesn't have a parent reference to the parent node. We just have int value left and right, and then yeah, this is the constructor. So I have initialized the instance variable called as lowest common ancestor node and instantiated it to null, and then calling a recursive method with root node p and q. We need to find out the lowest common ancestor of p and q. So here read root node and p and q. If node is equal to null, if the node that is passed is null, then that means we do not have any common ancestors for p and q. That means we can return false. Otherwise, present on left. If the lowest common ancestor is present on the left, then return it as 1. Then this means present on left is 1. Otherwise 0. If the lowest common ancestor is present on right, then it is 1, otherwise 0. If it is present in current, if the current node is one of the lowest common ancestor, that means I'm determining it by node is equal to p or node is equal to q. If node I is equal to either p or q, then returning it as 1, otherwise 0. and here present on right. Okay, all these things, after all these things, if present on left plus present on right plus present in current, if it has all two of those, all two, like present on node left and present on right and present in current, all three included, if it gives out the sum as 2, then that is the lowest common ancestor whenever it comes as 2. So lowest common ancestor is equal to node at that point, and then return present on left. Otherwise, just return present on left plus present on right plus present in current is greater than or equal to 1. That's the Boolean. Okay, I think it makes sense. Let me just rewrite this one. Just for practice, private Boolean. Okay, I think I would end up writing the same code because there's nothing too different or something to improve in that code as I see it. Okay, now if for the base case, if node is equal to null, then just return it as false. And then I need to see, not Boolean, I'm converting it into integer. Is present on left, how do we determine the present on left is equal to calling the recursive method with the node.def method, p comma ql, pass it as the same. If it's present on the left, then this will be 1, otherwise 0. And the same way, if it is present on right, I'll pass the right node here, then 1, otherwise no, 0. Int is current node. Then what I need to check, if node is equal to p or if node is equal to q, that means just 1, otherwise 0. And I'll have to check if present on left plus present on right plus is current node is equal to 2. If that is equal to 2, then update the lowest common ancestor node is equal to current node, and then return if one of them is greater than or equal to 1. Okay. Okay, this means I'm just responding that, okay, one of the nodes is present in the left or right, and then I'm using that information here to determine the lowest common ancestor node. Got it. I think it does the same thing pretty much. Okay, let's move on to the next one now. Power of x comma n. So here implement power of x comma n, power of x to the power of x to the power of n, which calculate x raised to the power of n, that is x raised to the power of n. X is equal to 2, n is equal to 10. Okay, 2 power 10, 1024. Okay, 2.1 power 3, 9.26, 2 power minus 2, 0.25. 2 power minus 2 is equal to 1 by 2 square is equal to 1 by 4 is equal to 0.25. Okay, here using the recursion, if n is equal to 0, if n is equal to 0, anything is 1. If n is less than 0, return 1 divided by my power of x, comma, minus n. Okay, minus n means that would become positive. Return x star, my power of x, comma, n minus 1. Okay, binary exponentiation, this is another method, but whether this one would satisfy the performance requirement. Okay, Stack Overflow error if we do this, but this is a basic version, so let's comment this one. It takes n number of computations, and then here in the binary exponentiation, okay, it works. So what is binary exponentiation? If n is equal to 0, base case, return 1. If n is less than 0, then 1 divided by binary exponentiation of x divided by minus star plus 1. So made that as positive 1.0. Since it's double, I multiplied by 1.0. And then binary exponentiation, that means if x is odd, then that means x multiplied by, if n mod 2 is equal to 1. So that means if n is odd. If n is an odd number, then x multiplied by binary exponentiation of x star x into n minus 1 divided by 2. X star x. Okay, in the single computation, I'm just reducing the sample space by 2 with every operation. Otherwise, return binary exponentiation of x star x into n by 2. That could work. Yeah. Just seeing one more time. If n is equal to 0, return 1. If n is less than 0, return 1.o divided by binary exponentiation of making it as positive value x star minus 1 star, okay, minus 1 star n, okay. And then if n is odd, then return x star binary exponentiation of x star x to n minus 1 by 2. If x is even, if n is even, then x star x multiplied by n by 2. Makes sense. Let's move on to the next problem. So we're done with 16. Let's do 20 and then call it a day. Copy list with random pointer. So copy list with random pointer. A linked list of length n is given such that each node contains additional random pointer which could point to any node in the list or null. Construct a deep copy of the list. The deep copy should consist of exactly n brand new nodes where each new node has its value set to the value of its corresponding original node. Both the next and the random pointer of the new nodes should point to the new nodes in the copied list such that the pointers in the original list and copied list represents the same list state. None of the pointers in the new list should point to the nodes in the original list. Okay. For example, if there are two nodes x and y in the original list where x dot random is points to y, then the corresponding two nodes x, and y lowercase in the copied list x dot random should point to y. Return the head of the copied linked list. The linked list is represented in the input or output as a list of n nodes. Each node is represented as a pair of value and random index. Okay. An integer representing node dot value. Random index is the index of the node. Okay, makes sense. Let's look into the solution here. Okay, each of the node has the pointer to the next node and has a pointer to a random node as well. And we are given a head node. If the head is equal to null, it's easy. Just simply return null. Otherwise, I'll create a copied head where new node is equal to head dot value with the head dot value. And I'm initializing another variable called as copied node and initializing its value to copied head, and node is equal to head. And I'm creating a mapping between the old node and the new node, or old node and the new node. So here the copied node or the original head, I'm adding that node map dot put original head, which is node, and then copied node, which is the copied head. I have added that to the map, and then while I'm traversing through the original node or the original head from the original head, while node not equal to null, if node dot next not equal to null, if node dot next not equal to null, and next is next integer. If node dot next not equal to null, if node map dot contains key node dot next, copied node dot next is equal to node map dot get node dot next. Okay, what they have done. Okay, if the node map contains the key node dot text, if it does not contain, we are not doing anything. If the node map contains the key node dot next, then copied node dot next is equal to node map dot get of node dot next. Okay. And then I'm marking here. Okay, what if I just do this? Okay, let me copy this just for reference. And then comment this one out, comment this one out. Okay, this one works. So I just overcomplicated it a little bit, reduced a lot of code here. Okay, here I'm checking if the node map does not contain the key. I'm adding the next element. I need to create the next element as a new node. So node map.put node.next, the corresponding one, I'm creating a new node, new node with value node.next.value. And then copied node.next is equal to node map.get of node.next. Okay. So this is for node.next value. And then I'm checking if node.random not equal to null, if node.random not equal to null, if node map.contains node.random. Okay, I think I can do the same thing here as well. So this one can be okay. Let's comment out this and then this can go outside here and then this can go inside here with new node initialization like this. Then okay, makes sense. I'll just remove this extraneous lines. Okay, now the code got simplified a lot than what it was before. So all I'm doing is I'm iterating through each node starting from head. If node.next not equal to null, then I need to construct the next node basically. So if not of node.map.contains key, then if the node map doesn't contains the next element, then I'm putting it into the node map.put node.next is equal to new node of node.next.value, and then copied node.next is equal to node map.get node.next. Okay, and then I'm checking for the same way for the random node as well. If node.random not equal to null, not of node map.contains key node.random, node map.put node.random, and I'm creating a new node here. Copied node.random is equal to node map.get node.random. I'm assigning the corresponding element, and I'm incrementing node is equal to node.next and copied node is equal to copied.next. I keep going through the next one only. Finally, I'm returning copied.head. So random also I'm creating the same way. And node also I'm creating the same way. If the random ones comes first, I would have created the random node before only, and then I would have added it to the map also. So that's why I'm checking if the map already contains the next node, then I don't even have to add it here. I will be just assigning it here to the next reference. Same way, if the next comes before random, I would have created the next. Random is not present. Okay, whichever comes first, either the next node or the random node pointer, I would have created it and assigned it in the node map, and I'll use it and just assign it in the reference here. Extends. Okay, let's move on to the next one now. Random pick with weight. So it's a LeetCode 528 random pick with weight. Okay, what is random pick with weight? You are given 0 indexed array of positive integers w, where w of I describes the weight of the ith index. You need to implement the function pick index, which randomly picks an index in the range 0 to 8 of length minus 1 inclusive and returns it. The probability of picking an integer I is w of I divided by sum of w. Okay. For example, if w is equal to 1, 3, the probability of picking index 0 is 1 by 1 plus 3, which is 0.25. And the probability of picking the index 1 is 3 by 1 plus 3 is equal to 0.75. Okay. Solution. Okay. The easier way is brute force approach to solve in its simplest way, but we'll run out of memory. So what I have done is I've created an integer list based on weight, new array list, and then for I is equal to I less than w dot length I plus plus, int repetitions is equal to w of I repetitions, and for the total number of repetitions I have just added that index list dot weight of I as many times as the number of values there, and then yeah, so that is the list based on the weight. And then for the pick index, I'm just trying to get the random index from the list based on weight and then dot size. So this could work, but we will run out of the memory in order to recreate all those things in the list based on weight. So another approach here is prefix sums. So in the prefix sum is equal to new int of w dot length, weight dot length. Populate the value for the prefix sum array. Okay, prefix sum is equal to 0. For int I is equal to 0, I less than w dot length I plus plus. Prefix sum plus is equal to w of I. So prefix sum is equal to prefix sum plus the weight of I. Prefix sum of I is equal to prefix sum. Okay. So I'm storing the prefix sum until then. And then now pick index, double random, prefix sums of prefix sum dot, okay, more than pick index. Find index is another one. Find using binary search here. Pick index. Let's see, random. So prefix sums of prefix sum length sums dot length minus 1 star mat dot random. So whatever the prefix sums of prefix sum length dot minus 1. So whatever the final value, that is the until then, star mat dot random, find the random plus 1 using binary search in the prefix sum array. Okay, got it. Return find index of prefix sums, whatever is closest to that prefix sum, closest to that random value in the prefix sums. Find index int of list, double target. Okay, low 0, high is list dot length, low is less than high, mid is equal to low plus high minus low divided by 2. Okay. If target is greater than prefix sums of mid, then low is equal to mid plus 1, otherwise high is equal to mid. And then finally when low is not less than high, I'll just return low. So this would work. So prefix sum is the way to go, and then binary search in order to pick the random from there. Let's go to merge intervals. Merge intervals. Okay, given an array of intervals where intervals I is equal to start of I, end of I, merge all the overlapping intervals and return an array of non-overlapping intervals that cover all the intervals in the input. Okay, given an array of intervals where start and end, merge all the overlapping intervals and return an array of non-overlapping intervals that covers all the intervals in the input. Okay, makes sense. So 1, 3, 2, 6, 8, 10, 15, 18. So 1, 3 and 2, 6, this will be merged, this can be merged to make it as 1, 6. And then the next one is 8, 10, that is not overlapping. So 1, 6, 8, 10. And then this one is non-overlapping as well, 15, 18. Okay. 1, 4 and 4, 5. That would make it as 1, 5. So even if the edges overlapping, that can be merged as 1, 5. Okay. So I'll have to sorting the intervals based on the start time here, based on the start time, interval of 0 and interval 2 of 0. And then output intervals I have initialized it as an array list, and then iterating through each of the list in the each of the intervals in the list, and then current interval is intervals of I. Okay, and output intervals is this one. If the output intervals dot e is empty, then just add it to the output intervals. If that is empty, that means it's the first interval, then just add it. Or else what we can do, okay, I think one way of doing this one is output intervals that add intervals of 0 if it's present. Let's not have that case. Okay, the intervals dot length is at least 1, so there won't be a 0th case. Okay, intervals of 0, and if that's the case, I can start with the first interval and remove this case altogether. Let's see. Okay, this one works too. So let's remove this one. This would make it much more simpler. Okay, here what I'm doing is I added the first interval into the output intervals array already, and then I'm iterating from the second interval, which has the index 1. I less than intervals dot length I plus plus current interval is intervals of I, previous interval is output intervals dot get size of my, which is the last, whatever is in the last interval in the output intervals. If current intervals start is less than or equal to previous intervals end, then merge the end time, merging the end time mat.max of current interval of 1, previous interval of 1. Okay, and then add it to the output interval dot get of, okay, output intervals dot size minus 1 of 1, adding the end time for that one. Else just add the, if it is not overlapping, then just add it, output intervals dot add current interval, do nothing. Output intervals dot to array, converting it into array, the to array new int of output interval of size, 2. Okay, output intervals dot size and 2. Okay, just provide the dimensions by making it as .toArray and then new int of the size cross 2. Okay, makes sense. Okay, now the next one is valid palindrome. LeetCode 125, it's an easy problem. Valid palindrome. A phrase is a palindrome if after converting all the uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters includes letters and numbers. Given a string S, return true if it's a palindrome or false otherwise. A man, a plan, a canal, Panama. So this is a true palindrome. Okay, race a car is not a palindrome. Race a car, not a palindrome. Okay. And then an empty space is a palindrome. Okay. So now is palindrome. What we are doing, I have the left is equal to 0, right is equal to s dot length minus 1, left less than right. Okay. If left is less than right and if the character is letter or digit, if the character is not letter or digit, then okay, character at left is not a letter or digit. I keep incrementing the left until it's a letter or a digit. And if the character at right is not a letter or a digit, then I keep decrementing the right. And then at the same time, I'm checking the border length as well. Left less than right, left less than right. If character dot to lowercase yes dot character left plus plus not equal to, I'm checking the equality. If the character at left plus plus is not equal to the character at dot to lowercase at right minus minus, then return it as false. Otherwise, once I check all that, if left is not less than right anymore, and if I haven't returned any false until then just return it as true. Makes sense? So this works. Let's check the number of questions that we did. I think we looked into 20 of those now. Valid palindrome. We can have another live stream in order to cover 10 to 15 of next problems. And then go ahead. In the morning, I'll try to create a live stream to go over 10 or 15 more problems. That should be good enough for FP. And then we can move on to some other companies' specific problems. So thank you for watching it. Whenever you watch it, please post any comments or any questions that you have. I'll make sure to answer those questions or address it in a way that makes it more understandable for you. Thank you very much. Good night.